This Core Java demonstration training video is provided by Chrysalis Educational Services.
Hey, I'm Ryan, and today we're going to be talking about Core Java. Core Java is really no different than any other language. I'm using English to translate ideas and communicate with you, whereas we use Core Java to communicate with a computer system. When you think about it in that context, learning Core Java is really not difficult at all. You start by learning the alphabet, then words, using those words in sentences, and finally grammatical rules. With Java, we have certain syntax and certain rules. When you understand these basic elements, writing Java code's really not difficult at all. In this course, you'll become acquainted with Java, getting it installed, first Java programs, data types, and operators. But before you run, you have to crawl. First, what's a computer system? A computer system is an electronic device. And because of this, the only way you can communicate with a computer system is through a series of electronic pulses. We call these special sequences of electronic pulses binary. Binary is indicated by a series of zeros and ones. A zero indicates the lack of an electric current, whereas a one indicates the presence of one. You can think about it a lot like a light switch. When the light switch is on, the lights are on. That would be a one. When the light switch is off, the lights are off. And that would be a zero. By using these on and off sequences, we're able to communicate an idea with the computer and receive desired results. So binary is very helpful in being able to communicate and achieve desired results with a computer system. But there are some inherent issues. First, it's really hard to remember binary sequences. Remember, we're taking complex ideas and changing them just into zeros and ones. For instance, to just ask a computer to add two numbers together, it takes somewhere over 80 characters of binary code. And remember, these zeros and ones all have to be placed very specifically, otherwise the request is changed. Now imagine if you were actually trying to do some complex coding, just how immense those codes would be. So we came up with a new language where we could give the computer simple commands like add. We call this assembly code. Assembly code made life a lot easier for programmers as they could use language they were accustomed to and still receive desired outputs from the computer. We do this through the use of a translator, which would be just like a translator you might use to talk to someone from a foreign country. We call that translator the assembler. The assembler takes your simple commands, translates them into bytecode, and feeds them into the computer. As with any new technology, there were some problems. First, assembly code is platform dependent. What's a platform? Basically, a platform is the combination of the operating system and the processor. A good example of this would be Wintel, a Windows operating system on an Intel processor. The problem with that is that assembly code differs from one platform to the next, and that creates huge limitations on assembly language. Another issue with assembly code is that it's very basic, and as platforms and technologies became more complex, it became very difficult to do complex programming with just assembly language. To remedy this issue, C language was created. C language allowed the assembly code to be huge, and it did so through the use of something called a compiler. The programmer could now write C code, which would be fed into a compiler. This would then change it into assembly code, which would be fed into the assembler, which would then change it into binary code and feed it into the computer. So we solved our issues with complex coding, but still had problems with platform dependency. Because assembly code still differed from one platform to the next, different compiler programs had to be created for different platforms. So finally emerged Java. I'm sure you've heard that Java is platform independent, and you can see what a huge advantage that gives us. Java code is written as a .java file, which is input into a Java compiler, which changes it into a class file. Now that class file contains bytecode. The bytecode is for a virtual platform that exists on RAM. We call that JVM. JVM recognizes the platform it's creating JavaScript for and translates the Java bytecode to a platform-specific bytecode. As you can imagine, that made life much simpler. Thanks for watching this course demo video. For more information, check us out online at mychrysalisedu.com.
Chrysalis Educational Services. We do more than training, we do careers. Contact us or click us today to register.